Here we are in the CCP studios, and the first thing that we teach in fundamentals is something that's really, really cool, and that is to show the most basic of all cameras, which is the pinhole camera. And what we've done here is to actually drill a small hole through the door, as you see there on the roller door, and that is, believe it or not, the basis of all photography. The idea behind this is that light travels in a straight line and we see by reflection. And so colours, interestingly enough, are what they aren't. Purple, we see purple because whatever fabric we're looking at, whatever object we're looking at, if it's purple coloured, it absorbs all wavelengths of light but reflects purple. And because we see by reflection, and that's something that we just take for granted, that is the basis of photography though. And so because we see by reflection though, do not think of light now travelling in a straight line at 186,200 miles per second, so much as light now hitting an object and scattering everywhere. And this is why we actually see the sky, trees, or the ground. That is to say, we can walk around an object and it has 3 dimensions because we have 2 eyes, which actually picks up the scattering of light from those objects. And so think about the ground. We see the ground because the light bounces up into our eyes. That scattered light continues on forever until it loses its energy. But in the same way that we see the sky because the light scatters everywhere, but downwards as well, into our eyes. Everything in the middle is not a problem, but the fundamental truth of this is that when we see these things, they're actually turned upside down on the back of our eye. There may be a little bit of background noise because we are in the studio, and we also have industry next door, so we're trying to make this as easy as possible, but just bear in mind there may be a few interruptions. So anyway, getting back to that idea of light scattering, it goes everywhere. And there's just a very small amount of light manages to pass through your camera lens. And that is the basis of photography. The camera itself is derived from the idea of the camera obscura. The camera obscura literally means room or chamber. We are in a chamber, we're in Studio 5 right now. Obscura means dark. And so what I'm going to do right now is to turn this chamber into a dark chamber, simply by turning off the light. Now, you're not going to see anything at first, except perhaps that pinpoint of light that's in the door there. But also bear in mind that pinpoint of light is actually capturing the view that we have outside. We have a building opposite us, we have a car park off to the right-hand side, we have another building that adjoins us onto the left-hand side. And so if we can capture all of this onto a little screen, which I'm going to place in front of the lens right now, and it is a lens, it's a simple lens. There's no glass in it to harness the light. All it is just a very small receptacle for which light can pass through, as you can see in your screen. So if I take this fabric and place it in front of this now to harness all of the light that's passing through this hole, the first thing you're going to notice is that everything is upside down. But that's explained because, of course, as the light scatters around, we have a conjunction where a few rays of light are bouncing up from the car park up to here. In the same way, the sky, we see that above because all the light is scattering down towards us. That's the bit that gets in through our eyes. The car park that is on the right-hand side is now on the left because it's inverted. And the other building that I mentioned is on the right-hand side. That's actually on our left as well, because of course everything is upside down and back to front. This is how we see, and our brain just corrects that. This is how your camera sees, and we just simply turn the images around so they're correct. Of course, inside your camera, we have a mirror that actually reflects everything back correctly for us so we understand what's going on. But the really interesting thing about this is that this light, not only are they rays, but because we have this circle here, they form cones. It's a cone of light. And so consequently, as I move this screen further and further away, the images get bigger, but they also become more and more dull as the light that's coming through that simple lens loses its energy. Now, if I take this in closer and closer, the image gets brighter, and it's also like a wide-angle lens. And so I always ask my students, firstly, what shape are photographs? And that's always met with a deafening silence. The fact of the matter is, though, all photographs are in fact round by virtue of this lens that is here. What we simply do is like what I've done with this fabric, is to truncate it just by a rectangle. There goes a car. And so consequently, all photographs are round, and that explains why when you've got a really, really wide angle lens, you'll notice here we've got some curving of the image actually beginning to start to happen. And that's really quite normal, because that's the way we see. There's a person walking across the car park right now. And so on this really bright, beautiful blue sky day, we have all this lovely colour here, and we can see cars going past. So it's kind of a cinema, as a matter of fact. But looking at this right now, if we've got a real wide angle lens, you can see we have the curvature here and the curvature here, which explains why if you're using a fisheye lens in a landscape mode, you get all the bowing on the far edges, left to right. If, of course, you put that in portrait mode, you're going to get those circles, now more prevalent, on the top and on the bottom of the scene. And this goes everywhere. Just by distorting this fabric, you can still see that the image is being seen, but it's just different sections of it that interrupt on this screen. So it's really quite fabulous. Now, we've known about this phenomenon since the 4th century BC. There was a Persian scholar by the name of Al-Bajan. He noted this very phenomenon you're looking at right now being projected onto his tent, upside down and back to front, and he found it very, very mysterious. Artists have used this phenomenon since then. So photography itself, though, photos and graphos, literally means to draw with light. And so drawing with light, we celebrate in 1837 when it's the chemical fixing of this process. Up until that point, artists knew of this. They would put up a canvas opposite the scene, they would draw around it, they would turn it around, and they would paint it in. Probably the best known example of that is Johannes Vermeer, who was very active in the 17th century in Holland. So check out his work. The reason why his images look photographic is because they pretty much are photographic. All he was doing was tracing around them. Now, I mentioned earlier that we see stereoscopically because we have two eyes. With the camera, the reason why images look not quite right from life is because they aren't quite right from life. They are seen monocularly or with one lens. In the same way, if you were to close one eye, you actually lose all depth perception. You need that second eye to actually mirror or marry up those two images to give us a sense of space. So images drawn from photographs look more photographic than they do from life. Images drawn from life look more three-dimensional than photographs. But nevertheless, photography itself is here to stay. And this is really the best way to actually explain what happens inside that magical black box when you take an image. Here is our zoom lens. And the building gets larger and larger and dimmer, but it's still there. Now, we just have the one lens in the door to give us the one image. But if we had several holes drilled right across this door, we would actually have as many images projected as we have holes. They would all be from a very slightly different perspective. So it's not just this particular door at this particular point. You can make a pinhole camera anywhere. But what you really need is a dark room so you can see this dim image. In the same way, the stars are still in the sky. But we don't notice the stars right now because the sky is much brighter than the stars. So when the sky starts becoming gradually darker and darker, so too the stars relatively appear to be brighter and brighter. And so this is photography in its most beautiful and basic form, the pinhole camera. Now I have G holding the screen right now because something the students always seem to like is when I leave. And what I mean by that is that you may have seen a car go past, but we're now going to animate this live with me in front of the door. So first thing you notice as I open the door, the image seemingly disappears because we now have much brighter light than the image itself. But with me closing the door, I'm coming in from the left-hand side. But I'm actually going to appear to be coming in from the right according to the image. So I've lost some of the beautiful sky now, but you can see me. So standing out there in front of the image, you can see that I'm upside down. And I'm zooming in now as I get closer and closer. I'm tapping on the left, but I appear to be tapping on the right. I'm moving to the right, but I appear to be going to the left. And the really interesting thing is just how wide this angle is, as a matter of fact. But another feature of cameras, needless to say, is the lens cap. And that always brings a laugh from the students, so I hope you're laughing too. I'm going back inside. I'll see you soon.